Hello guys, in our last video we saw the demonstration of the equipment, the advanced oxidation from the brand GUNT. So now we would first of all we'll switch on the device. So now we are switching the pump, then we'll switch on the UV lamp. Okay, so this is our dye rich water or the water that has to be treated. To this water we are going to add the catalyst, that is TiO2, titanium dioxide. This is around 50 milligram. So after adding the catalyst, you can see there is a the catalyst is well dispersing in the whole solution. So now we are adding around 50 ml of the hydrogen peroxide. Solution is here, which is hydrogen peroxide. And the water that is going to be treated is around 10 liters. So you can see our initial sample. The first sample that I'm going to take. Second sample. Simultaneously I ran the whole equipment for around half an hour, and I took the sample for every 5 minutes. So you can see the whole device. Okay, and we used TiO2 as a catalyst. So the drawback of this catalyst is that it produces a kind of some intermediates, which is really not good to dump it into the sink, or to the sea or any kind of river. So now we would take the sixth sample, and then we will quantify it to check the amount of the methylene blue, because we are going to treat we are treating the methylene blue here. And then we would draw the plots and also see the kinetics, whether the concentration is or the efficiency is increasing with the time or not. We would centrifuge our samples in order to segregate the catalyst from the liquid sample. Okay, so as I told you earlier, we are using TiO2. Instead of TiO2 we can use other activator or catalyst like potassium persulfate or ammonium persulfate. Okay, there are other available catalysts in the market, or the Biochar LDH or the LDH. So now we will centrifuge it. Now we have transferred the samples to the vial, and now we are going to centrifuge it. Okay, so we will centrifuge this for around 5 minutes. Then first step is you have to do 0. This is our stored program for the methylene blue dye. After centrifugation we will take our samples. So this was our first sample. We will put them in trays. Then this is the second sample. Simultaneously we will fill all the trays. This is our initial sample. So the concentration is around 3 ppm. The concentration for the second sample, okay, is 2.21, so it's a drop. So the concentration for the third sample is around 1.872. This is also a drop. Simultaneously for the fourth sample, which is around 1.542. Now for the fifth sample, It's around 1.392. Simultaneously for the last sample, it is 0.814. So this is a big drop. But if you compare with the other catalysts that is available in the market, they perform much better in my experience. See the trend here. Initially it was 3.116, then it dropped to 29%. It was degradation, then it dropped to 40, 50, then 55, then 74% degradation. So in the near future we'll be using a different kind of catalyst, and then we would see the trend, how it performs in terms of degradation or removal.